In this 20-25 minutes, we will introduce you to how we use EasyBuild at CSCS, the Swiss National Supercomputing Center. So this presentation is mainly based on the work done by Guilherme, my colleague at CSCS, and Victor as well, who is in the audience, who contributed to the implementation, while the framework of importing EasyBuild on the Cray programming environment was mainly done by Guilherme with Kenneth and Petar Foray from Vienna. So let's go to the outline. I will start with the traditional beginning, why using EasyBuild. Then Guilherme will talk about the experience on porting EasyBuild to the Cray programming environment and showing a couple of use cases on two different computing systems that we have, the flagship one called PITS-Daint and a smaller system called PITS-Cache and PITS-Esha. And then we will conclude by showing briefly our software builds, automatic software builds using Jenkins. And we conclude with some, let's say, proposals maybe for improving the framework. So why using EasyBuild? As you all are aware, there is a lack of standard way to describe build recipes in general among different softwares. So our group at CSCS is an scientific application support group. So we need to provide an up-to-date software stack to our users that are mainly academic users. Different softwares have really different recipes, and EasyBuild helps having a uniform approach to build that automatically. And then also the software available is very heterogeneous, so you can have accelerators on some machines while on others not, or different operating systems, and EasyBuild then helps you moving users from one machine to another one. Then sister upgrades. Anytime you have an operating system upgrade or maybe a new CUDA driver, you need to test software, you need to rebuild everything. So EasyBuild helps a lot in this case in order to avoid manual work, to redeploy the software stack. And then collaboration, which has been underlined in the talk before. There's a little collaboration among sites in general, while EasyBuild has the advantage of creating a network of people that basically have the same goal of building software for HPC systems. So in summary, for our experience, EasyBuild has the advantages of being an open source Python framework, so it's quite reliable to build scientific software. Then it helps maintaining multiple software deployments, then downloads, compiles, and installs the software automatically, also resolving dependencies. And then it is adopted by several HPC centers, including Cray systems, which are the main ones that we have at CSCS. One of the major advantages that we are using now with our user community is letting the users build their own EasyBuilds. In the sense, we provide them a certain set of recipes that we made available on the GitHub project CSCS production, so it's public. And anytime a user has a specific need for something that we do not provide in our software stack, but can be easily retrieved using try software, try toolchain, or slightly modifying the easyconfig file that we provide, then we suggest to do that. So the user installs on the software on his local files. And Victor and Guilherme provided a simple way of doing that with the EasyBuild custom module file that we provide on our systems. And then if the user uses the defaults, then gets on his home, he gets the module files that can actually configure if they want. They can just clone our repository in order to have the good folder structure expected by the module, and then they can share that with the group. So maybe just one of them, there usually is in research groups one geek that can do things and then share the builds with other colleagues. And that makes things easier for us because users generally comes with a lot of different needs and different versions or plugins that they want to. One of the things that I think yes, please.
question related to this. So what you provide are the recipes for the stuff you provide on the system, but when users install their own stuff, they would rebuild all of this in their home directory, or would this be taken
No,
from
because
the system?
generally in the module path it is already available, our software stack with the standard recipes. So everything that is based on that will not be rebuilt in the local home. So only specific things that the user might edit, like they want to use a different easy config file, then it will of course rebuild something. But unless they have specific needs for the software stack, then they will build upon that.
Yeah. So for me, just having it in module path was not enough. So that's why I'm curious.
Well,
why
if
it works.
EasyBuild finds the same module name in the module path, doesn't rebuild that.
Are you using flat naming scheme?
Yeah.
Yeah, okay. With the flat one, it works. With the hierarchical, it doesn't.
Yeah. Well, we don't have hierarchical.
Yeah, okay. That makes sense then.
Yeah, I didn't mention that, but at CSCS, unfortunately, we don't use L-mod. So we have the TCL modules for the moment. Anyway, so one of the main advantages that I see, that I mentioned, is of EasyBuild is that it's a great collaboration network. So I've spent some time taking the affiliations from the emails that I've seen in the EasyBuild mailing list as in contributions. And I think it is a great work that has been done by the developers in order to create such a community, because, okay, it is mainly based in Europe, but it spreads across the ocean, and it gets even to Australia and New Zealand. So I think it's a great achievement. Then I don't know how many of them usually use EasyBuild in production, but at least they contribute to the mailing list, so it means they are interested at least in that, and that's, I think, a good sign. So for the next two sections, I will leave Guilherme talking about his work that he did with Petar and Kenneth.
Okay, so it is actually Is it on already?
Yes. It's on mute. It was on mute. It wasn't on, it was on mute.
Okay, better.
So, well, whatever.
Okay.
You stay with that one.
Okay.
Yeah, go ahead.
Now it's
Yeah,
okay?
yeah, I see
Okay,
lights.
yeah. Okay. So just for the people on stream, so now now that you can hear me, so the main difference on Cray system is that we have a software stack provided by Cray, optimized, and then with EasyBuild, we just want to use that instead of rebuilding everything from scratch. So if you look at the FOSS tool chain here, there's more or less a one-to-one mapping to what Cray has, except for FFTW that we don't include on the programming environment by default on Cray. So what Peter and Kenneth did is to create the tool chains that map to this existing software. So the first thing that we had to do is to support external module files. So EasyBuild generally creates all the module files, and if it's not provided by EasyBuild, it doesn't read, cannot reuse. So this was implemented. Then they defined the Cray specific tool chains and the EasyBlock for the tool chains. Okay, so a big thanks to Peter and Kenneth again for this work. So the support for external module files worked like this. We have like a file where we put the external metadata for the module file. So we map the existing modules in a way that EasyBuild can reuse. So we define the EasyBuild route, so EasyBuild can easily find the paths and then can reuse it as if it was a module created by EasyBuild, let's say like this, even if it's external module. So this is used mainly on the Cray, but it doesn't mean that it cannot be used outside Cray. So anyone having existing modules can use this file to specify to EasyBuild to reuse it. So this is something that it was for Cray, but it can be reused outside Cray if needed. So since EasyBuild 2.7, we have this file containing the let's say a standard example for one version of the programming environment from Cray. We have this file that you can just take it, reuse as it is if you have that version of the Cray programming environment installed, or you just adapt it to your site, updating the versions and so on. So the easy blocks that were created for the Cray, this main thing that we had to be careful is about the versions. On Cray, they are they don't pin versions for the programming environment, so this is very tricky because the defaults might change over time, and then of course the builds will fail because it's not ABI compatible. You can move from CUDA 7 to 8, and then if you just try the same build, it will fail. So we decided to pin the dependencies for the Cray components of the programming environment, as we do in EasyBuild everywhere. So that fixed the problem of reproducibility, and then on top of that, we just create new easyconfig files for specifying this version. So that's how it works. So we started. Peter and Kenneth did this tool chains for the programming environment from Cray, from GNU, and from Intel. The last one was made by someone at CSCS. Jean-Guillaume did the programming environment PGI. He needed, it was missing, so he just contributed back. I think that's the story. So basically what they do, each of these programming environments, they just wrap all the variables that are needed to use the Cray. So as we do in the with Intel and GCC compilers on Cray, we use the wrappers that are provided by Cray. It's the only way of having the MPI working in all the libraries. So the users and EasyBuild itself, they need to use the wrappers in order to build software. So that's basically what the tool chain does. So the main implementation of Cray on EasyBuild is, I think more or less you have an idea of how it was. Now I want to show two use cases using on Cray. So the first one is for Meadow Swiss on a CS Storm system. So it is Cray, but we don't have the Cray programming environment. So here I will go back to standard EasyBuild, just it is Cray, but it's not using the programming environment. Then I go to PitsDyn, which is our main system, with this Cray XC, where they have the programming environment from Cray, and then we use this thing. So just before going that, there an overview of our system. So we have PitsDyn, and then these are all the production systems we have. We also have TDSs. So we have one system for Metal Swiss, one with large memory, and our main system is PITS-Dyned with GPU. So this is just so that you have an overview of our main production systems. So going to the Meteor Swiss use case with the CS Storm, here as the particular thing of this system, it is the first weather forecast production system based on GPU. So it's very dense. The nodes are very GPU dense. So 8 K8 is per node. That means 16 GPUs, and it is used in production since a long time ago. With a long time ago, 1 year and a half, with EasyBuild. It is now in production with EasyBuild. So in this case, as I said, the programming environment is not complete from Cray. So the problem we had when we received this machine is that GCC was not compiling AVX2 instructions for Haswell, and the machine was Haswell based. And we opened the ticket with Cray to complain about that. And in the meantime, we just tried to rebuild everything with EasyBuild, because with EasyBuild it was working. Since EasyBuild, the FOSS and the other two chains, they added the bin utils compiled by EasyBuild, so it was a recent one. So from scratch, it worked out of the box with EasyBuild, and with a Cray programming environment, we had to wait for a long time for a fix. So by the time they gave us a fix, we had the whole software stack working with EasyBuild, and this is the one that I mentioned. It is now in production. So thanks Cray for the programming environment, but then if it's not working, we find another solution, and that's free market. So now let's move on to the PITS-Dyned use case. So this is our flagship system. Before, maybe you heard about PITS-Dora, which was the Broadwell system without GPUs. Now it is merged with PITS-Dyned, so we have two partitions. This table is just mostly to show that we have a partition with the XC50 and the new Tesla P100, the Pascal GPUs, and a partition with the old Dora. Let's say if you knew the system, it's the Broadwell, so only multi-core system without GPUs. So just one slide to understand let's say how powerful the machine is. So it's number 8 on top 500 from the last list. So it is number 1 in Europe. The numbers are not yet final. The machine was not ready, so you'll probably see new numbers in the next list, but I cannot tell you the numbers. And it is number 2 in the Green 500, and this could also change on the next list as well. So what do you get right now if you want to use EasyBuild on Cray? So if you look at the stock repository, you can find already a couple of applications, important ones for us. So Wharf, CP2K, Gromax, and Python, which was our first use case with all the accelerated NumPy and SciPy, which is largely used at our systems. And if you want to use our recipes that are in production, so you might find site customizations, you can go to our production GitHub repository, which the link is here, and it will be in the end also. And then you can just do a git clone and reuse. We have EasyBlocks and EasyConfig files there, so you can just reuse it. So you can see the list is much bigger. So now we are not really contributing back much. We probably will if we have other Cray sites using, but for now I think we are happy with the solution. We have our recipes open and public, so if other sites want to use, they are available. So one slide on the usage of our system. So this is a new thing we have since the upgrade of PITS-Dyned in December. We installed Xalt. It's not yet fully working, but we already have some data on the usage of our system. So we can see on the left here the top 10 executables. We can easily spot what are the shining stars of PITSDYNT are CP2K, Quantum Espresso, and VASP on the compute hours. And then this helps us to understand where to focus our efforts. So this is, let's say, it's more a publicity on Xalt than on EasyBuild, but then we can also understand our modules where they are being used. And on the right here, you have the number of active users on the system, so you can just to have an idea on how many users we have to help in general. So the blue bar are the number of users running jobs, so you can see it's from 150 users to 200 users running jobs at the same time. And the red bar are users compiling code, so you can see that it's heavily used. This is for 1 month. Yeah, 1 month, right? Yeah, this is for the last month. Okay, so now this is how we integrated all these with continuous integration. So as I said, we had this GitHub repository with our recipes, and the idea now is that everyone in our team doing EasyBuild recipes that are going to be supported or given to the users, they must follow a pull request procedure, so that we are all in sync, that the recipe is, I would say, correct. So it's more or less what Kenneth does before going to the official repository. But here, of course, the rules are not the same because we have site-specific customizations. And on top of that, we have automatic checking of the build recipes, meaning that we have a plugin from Jenkins that is checking every commit or every push on an open pull request to see if the recipe is working on PITSDYNT. So this is a pilot project on PITSDYNT we want to use on other systems also. For the moment, this is very new. We are using since 1 month, and we are very happy with it, because we have very easily an idea if the recipe is already working. We don't need to manually check. So if we see the green light on GitHub, means it has been built and installed on PITSDYNT. So it helps us a lot. We don't need to manually check, and also it is less error prone, because usually people, when they are testing things, they are using their own shell, which they have custom bash RC files, they have exports, they play around, and then you have the very old thing saying it works on my terminal, but not on yours. So Jenkins is a common ground for everyone. It needs to work with Jenkins. If you do tweaks on your shell, it's your problem. It should work with a clean shell, and then that's the rule for us. So this setup really helps us to make sure that things are working, and I don't need personally to go and test with my account to see if it's working. So this is something that is really helping us to have this, let's say, clean set of recipes. So the last thing is the deployment of this software. So first part is just to test the pull request. Then we have another list of easy config files that we say that we actually support in production. So we have just a text file with the names of the easy config files that should be deployed on production. So this is where we control what should be installed and what should be deprecated. And then once we do a pull request and we change this file, Jenkins will automatically trigger a build on production. So we don't install software by hand anymore. So we just create recipes, we add to the list on GitHub, and then Jenkins does everything. So it's a change. We don't have any manual intervention, and then we know if we need to rebuild everything, it has been done by Jenkins. So it's let's say it's a clean.
Just a question: is that happen in real time, or is that during a downtime or something? So you're like replacing, for example, if you had to rebuild the software, you're doing that live, right?
Rebuilding, it's different because it will check if it's available. So it's not rebuilding every time. So if we need to rebuild, it was actually the case for a couple of things. We have another project, then we need to force. So for rebuilding, you need to, let's say, open a different project and say, I want to rebuild that one because it's already there. So EasyBuild, we don't want to use to to force every time. So we use the force only when we need. So that's, and for the rest, we have just pulling. After a couple of minutes or 1 hour, it will be seen in production. So. Okay. Any question on this, on the setup here? Okay, so this comes from the talk on FOSDEM. So it was just a final word about the current implementation, meaning that proprietary software and open source can coexist, in the sense that we do want to use the proprietary stack from Cray whenever it's an advantage for us, but we don't want to be stuck with that. So here with EasyBuild, we have this feeling that we have the best of the two worlds, because whenever we need open source software, we just can try beside the proprietary one, and then in the future we might start also comparing how does the EasyBuild config files will do with MPI also on Cray. So in the future, we don't want to be stuck with Cray for the rest of the life. It's just sometime in the future they might be giving not a good stack, so it's good to have the opportunity. So it's one of the things that we want to try out in the future, is to do more and more open source. So this is something that EasyBuild can help us. Okay, so despite that I have the Jenkins t-shirt, now it's Luca who's going to talk more about the...
Yeah. Okay, thank you. So it's already on. Yeah, well, there's the part in building software with Jenkins that you probably all know, so I might go fast on that, because so you know that Jenkins is an automatic tool for continuous integration and validation, and the advantages are that you have a lot of plugins. So as Guillermo already said, we recently implemented a plugin that pulls and does the continuous integration once we update our recipes on our GitHub project, and that comes handy because it avoids using manual job. And other usage examples that we have at CSCS of Jenkins, apart deployment of the software stack, is also the validation and regression testing of applications. So we have, let's say, a life cycle of our recipes. That is, everybody in our group is responsible of a set of applications. So we start from the EasyBuild recipe to the regression test for the application that we are building, plus the integration with the Cray performance and analysis tools in order to retrieve performance metrics of the test that we've been running in the regression. So that can be done everything within Jenkins, and that's helpful because you don't need to rely on a specific person. You have a Jenkins project. If the person is not there, it will be run by somebody else. And it was very useful also in the case of upgrading or deploying a new HPC system. So the acceptance was actually driven by Jenkins projects. And one example why we like it, you can very easily have this build time trends in order to check. For instance, this is a regression test with the Cray NetCDF HDF parallel module provided by Cray, so NetCDF4 with HDF5 interface in order to see the right speed on the raster file system on Scratch. You can spot immediately a problem with the peaks, or the build time trend on the Esha and Cache Meteoswiss systems at CSCS for the whole software stack. So everything is more or less easy with that. And this is also an old slide related to the workflow that has been now implemented by Guillermo on the system in order to have the automatic builds once you actually push a new EasyBuild recipe of a new software. I just go to the end, the conclusion, because it's a bit late. So in our experience now, the current EasyBuild installation that we have, so for the application support, is ready. It provides Python support on Pitsdent and Esha and Cache. And in particular on Esha and Cache, it relies on the standard EasyBuild toolchain, GM both, while on Pitsdent there was the need to have the Cray toolchain. So the continuous integration and validation techniques have been applied successfully, and it shows that in order to get the most out of EasyBuild, let's say you really need to have a consistent programming environment across Cray systems and non-Cray systems, which is achievable with EasyBuild if you are on a non-Cray system. Work in progress. Well, the stable Cray support is already there because the issue has been closed in December. The issue that you see here in the link has been closed in December, and it has been presented in a paper by Guilherme, Kenneth, and Peter. Then the RPath support needs to be tested also on the Cray system, and still it has been mentioned the compatibility with other similar projects like SPAC in order to automatically build software. Now, one of the things that has to be worked a bit more probably in our experience is the, let's say, easiness of adopting the EasyBuild framework for new users. For instance, a new user that wants to build, now that we have actually advertised the EasyBuild with our users, has to cope with EasyConfig, sometimes with EasyBlocks, and sometimes they want to know about the framework. So maybe these 3 steps can be reduced in 2 steps, like integrating the EasyBlocks with the framework, reducing the number of EasyBlocks, and using more the EasyConfigs, as you have pointed out, Kenneth, maybe with YAML files, that might be a possibility. The extended dry run also comes very handy, and what can be improved. So we have some proposals, like implementing new command line for try also dependency versioning, because sometimes you need to provide by hand some dependencies in case you edit a new EasyConfig file. The backup of custom EasyBlocks, like you have once you install a new EasyConfig file, you have the EB files repo where a copy of the EasyConfig is stored. That might be useful also for EasyBlocks that are not in the framework but have been used by the EasyConfig by the recipe. Also, for external modules, it might be good to improve the error messages when there are missing modules in the metadata file. And also, it could be useful to provide a versionless entry in the metadata file so that you don't have, anytime we have a new CUDA toolkit, for instance, we need to update the metadata file with just changing the version, which probably can be done without as smoothless in another external metadata file format. And then flexibility for tool chains, like creating or modifying tool chains without changing the framework, so having on-the-spot tool chains, and integrating EasyBuild with existing compilers. So last but not least, it would be nice to have a command line option to say, EasyBuild, please make this module file default, because we implemented a hack in order to have some .version files in our module file folders, but that could be also easily implemented in the framework. So to conclude here, there are some links that will stay in the presentation. The project of EasyBuild at CSCS on the GitHub with a wiki, how to build for users new EasyConfig files, and our EasyConfig and EasyBlocks repository with custom EasyConfigs. If you do want to know more about EasyBuild on Cray, then you find the link to the PDF of the paper that has been published by Guilherme, Kenneth, and Peter, and some EasyBuild links that you probably all know. So thank you for your attention, and if you have questions, now we are ready to take them. Yes, please, Kenneth.
Can you go back to your second to last slide? One more. Yeah. The flexibility for toolchain definitions, I think that's already there, what you want. We have include toolchains. So you only have to define the Python module that defines the toolchain. You can add your own compiler support and MPI support and stuff like this. You still have to write the Python module, but I don't think there's a way around that. It doesn't have to be included in the framework. You can have it sitting anywhere, just to include toolchains, and EasyBuild can pick it up. So I think that's what you want here.
Yeah, I think so.
It's even documented.
probably it was something older that stayed in the
Maybe,
slide.
yeah.
Maybe
And
it's my fault.
can you go one level back?
Here?
Yeah. What did you mean about compatible build description with similar projects?
So, for instance, interoperability with other projects like Spark, in the sense having the possibility.
You want to be able to, like we did with Conda, use Spark from within EasyBuild, just call out to it as a build tool?
Yeah, it might be nice, in the sense you might get more users that would like to adopt also EasyBuild if it can include also other projects like Spark.
Yeah, makes sense. Yeah. It doesn't matter. I mean, we can call out to anything. If we can make it work with CMake, we can make it work with other stuff.
I think it was second to last. No,
this one.
That one, yeah. So when you say --tribe, that version, I think that's more or less aligned to what I wanted to do as well. Maybe we can do something together to have a more powerful approach. Don't just try that version, but be able to extend that and do what I intended to do. What I intended to do was a bit more easier and flexible, in the sense that just consume what is there. But we can have both things at the same time, and maybe have a more powerful syntax to support both things. And I think that's aligned. I think that's aligned both ideas. So yeah, just that.
Great, thank you.
There's another question. Sorry.
It seems like you've had to do a lot of work to cover up for Cray's deficiencies. Have you tried to sort of lean on them to work in a more compatible way, to maybe incorporate EasyBuild into their own internal stack, that kind of thing?
Yeah, that's a good question.
Yeah, so we try to talk with Cray. They are not very open to supporting other software, especially I think if they realize that it could replace their software stack. So it is something that they sell. It's a selling point of the Cray is that the software stack provided by them. Then they are not really happy. At least they didn't seem very happy to support us on using EasyBuild. So yes, we did contact them.
That's also why we submitted a paper to the Cray user group to like show it to them and show it to the Cray community. Look, you can leverage EasyBuild on Cray systems as well. So that was like the first step. But yeah.
So the idea for us, it would be nice if other sites start using it. Then we can make pressure. But just one site, probably every site has its own build tool. So now EasyBuild for them is the same as other build tools because it's used by only one site. By the time we have more sites, then maybe they will start a discussion. That's how it works. If you're dealing with vendors, that's how it works generally.
Sure. The other observation was I was very interested in the sort of periodic automatic testing that you're doing, and maybe sites could collaborate on making that publicly available, and then we'd get there would be less sort of bit rot where, you know, download files break and locations break and that kind of thing. So maybe we could discuss that.
Like having a central Jenkins server where everybody can publish.
Either central server or a kind of federation of sites who are interested in doing it.
They're looking into something like this in SPAC as well. They have a central C- setup where they want to allow sites that use SPAC to push their test results to the central setup and have a better view of what works and what doesn't work. So that's one of the ways they're trying to get SPAC more stable, is to promote more testing and also centralize that. So it's a good idea.
I mean, I'm not very familiar with Jenkins. So, like, is it possible to share that kind of a setup that you have at the moment, or how do you configure stuff in Jenkins? I don't know.
So, of course, we can share. It's not something that you can. We need to move that to pipelines. It's something that I found out
at FOSDEM that the way we currently do, it's a little bit hard-coded. We cannot share the setup itself, but we can show you how we did.
Yeah.
We are going to move to pipelines, and then maybe you can just make it public, all the project, and then you could reuse more easily. So for the moment, I could just do a screenshot of the steps, and then you can redo it. That's more or less how I could share. But there's a proper way of doing that. I just learned that recently, so we can. Okay.
We use Jenkins internally as well. We have a private Jenkins server, mostly for testing our own scripts, and we write unit tests for it and make sure nothing breaks. The way you configure Jenkins to run something like they do here, testing and also pushing to deployment, they have a web interface for it, which is okay if you don't have to change the configurations over and over again. But you also can like have a job definition that you put into Git, and you just do a Git push and it updates on Jenkins, it refreshes. So there's good ways of doing that.
I want to add also that for us, looking at something like that would be also very, very interesting, especially when looking into deploying in more systems, deploying EasyBuild in more systems, to have something homogeneous across different machines on one side, and probably have something that is shared across sites. That would be probably the next step after that, and I will be very interested in that. There's another question, but we have to make it quick because we have a remote talk at 1 and we have lunch break. We are actually 25 minutes late on the lunch break, so we have to really, that has to be the last one.
Yeah, it's more of a comment rather than a question. So as far as I understood Jenkins, you can also set it up so you need the central server, but there can be multiple clients actually executing builds, right? And so maybe this could be a community effort that someone sets up the server and allows other clients to build stuff. And if multiple sites get together and dedicate a node or so for building, that may be the way to go.
I know one application doing that already, so we could first talk to them. They are not using Jenkins, but they have this distributed thing. So CP2K, they have this method that all the users of CP2K, they are able to submit somewhere the results. So even if the people from CP2K, they don't have access to the systems, they have somehow in a centralized place the results from the test. So we should talk to them. I think it's a starting point for
that's really interesting.
So just a small comment, because we were using Jenkins for one of our neuro simulator projects, and the problem what we have to maintain the server, infrastructure, everything, and that's why we moved to Travis, because it's open source. You don't have to do any kind of maintenance of the servers and other stuff, and you can deploy, like if it's an open source project, you can have some kind of, I don't know, 200 build jobs or something like that, so it's free. So you get an empty worker machine and you can install whatever, and you can test with multiple OS and multiple Python versions. It's quite, yeah, we find it really good that Travis is better than Jenkins for our projects at least.